We design a lot of timber frame structures as well as post and beam structures. Timber frame, post and beam, those phrases get thrown around a little bit. They're not technically interchangeable, but I would say it really doesn't matter all that much. Timber frame itself technically has mortise and tenon joinery and is the old world, old school technical way to build things with mortise and tenons. Post and beam construction talks about posts and beams and how those combine to create the same shape and same type of structure, but without the same style of joinery. So in this one, we've got a couple things that probably are helpful to call out. And one's the dimension of it. We call the dimensions out from post to post. It's 12 this way by 16 this way. And you can see everywhere we've got posts, we've also got a beam on top running this way. And the beam supports the trusses on top of it, which is the next part up. Above that, you'll see these lines that are running back that way, and those are the timber purlins. Those are a 4x6 dimension. And on top of that, we've got a eastern white pine roof. Eastern white pine is the tongue and groove that was put up pre-finished for this. So from a force standpoint, you want to make sure that it doesn't move this way, right? It doesn't want to, you want to make sure that it doesn't rack. And our winds come in from the north. This is oriented mostly north-south, and our winds come like crazy from here. So we want to make sure that our forces are controlled. So we've got a couple things for that. The posts are all set in the ground, and they're set with a Simpson bracket. The next part that runs up and helps control some of the forces on it are these custom spiderweb brackets that I had fabricated and worked with from a local person. Also, we've got these additional lower brackets that are down, and all of those help to control the wind from pushing this structure and racking it that way. The other thing that we want to make sure of is that it doesn't move laterally. And so the knee braces that go from the truss lower cord down to the post are all lagged in place in a couple spots, and that makes sure it doesn't shake this way. If a building shakes, if it moves like that, that's when you're going to start having joints fail, and it's going to start to move and blow over. So that's just protection from wind loading. On top of this, each place you see a post, you'll also see it run up to a truss. These are queen post trusses, meaning they have two vertical members, one horizontal member that go up from the king and queen posts, as opposed to a king post truss, which would go up the center and have webbing that would go up the sides. And then you've got truss rafters that run down to support the purlins on top of it. So just a quick look at what I would say is not really a timber frame pavilion, but a hybrid post and beam pavilion. Again, the outside shape is pretty much the same. You really don't notice the joinery. You do see that we kind of hid on the back side our shutoffs for lighting and for line voltage runs that are run up there. But again, the overall dimension, the overall look of the structure really doesn't change whether you have a post and beam or whether you have a timber frame. It's really just about the joinery connections and a little bit, I would say, simpler and faster and maybe less brain intensive way of building a structure if you go with a hybrid post and beam. Oh, and there's our cat.